Alright, so this render tutorial is divided into 5 parts. One-time setup. Once it is done, you don't have to do it again. Essential Blender settings. This one you have to put into a habit of doing it if you're always rendering through Google Colab. How to render. Pros and cons. Google computing time. One-time setup. Create a new Google account and access Google Drive. In Google Drive, create 2 Google folders. You can name them anything. In my case, it's project and export. Download Blender setup file for Linux, upload it in Drive. Then open the link in the description. You will see this page. Go to File, select Save Copy in Drive. This will open a new tab with copy of Blender Cloud Render. This file is automatically saved in Colab Notebook folder. Essential Blender settings. I hope you have a separate folder for every Blender project. Once you are done with modeling, animating, go to File, External Data, Automatically Pack Resources. This will pack all the material texture into blend file. Then go to Render Properties, select Cycle. If device is grayed out and stuck at CPU, don't worry. I have set up external settings in Script where render engine is set to cycles, device set to GPU, and device type as optics. I have some presets for rendering. These are the best settings which give me good quality samples and take less time to render. Then go to Output Properties, select your resolution, frame rate, and output settings however you want. After setting up everything, save your blend file. How to render. After saving Blender project, I have uploaded entire project folder simulation test inside Google Drive folder projects. Now open Google Colab Script from Colab Notebook folder. You will see a menu. For Blender version, type exact number as it is on Blender setup file. For me, it is 3.6.2. In input name, Blender file name with extension. Folder path, you have to give directory as to which folder you want Colab to copy from Drive to the Google virtual machine. For me, it is project/simulation test. There is a checkbox next to animation. If it is checked, it means the entire animation frame will be rendered. If it is unchecked, then whichever frame you have mentioned in start frame will be rendered. Give an output name for your render file. Drive output path, I have set export. Here is the example. I want to render single frame, so I uncheck animation, set start frame to 192. Rest of the settings are set. Then I go to runtime, run all. After rendering is done, give it 10 to 20 seconds to move the files from virtual machine to Google Drive. And that is the frame that rendered. If you go to Google Colab Script and scroll, you will see 6 cells. Each one of them has name and what it actually does. If there is any error, you will see them under each cell while they are executing. Some errors are ignored, don't worry about them. If you have set all parameters right, you won't get any errors at all. Pros and cons. You can pause and read the pros. First con is you have to keep the browser active. For this, I will add a video link which explains how to tackle that scenario. And also added the JavaScript code at the bottom of the Colab script. Third con is the risk of disconnecting sessions. This will only happen if you are heavily using GPU. For example, if your project has 1 million polygons, photoreal lighting, or more than 100 materials and textures, then it will slow down and disconnect. For this, I would suggest to keep the frame size under 200 frames. Second con is render limit. People say that you can render 12 hours only and after that you cannot render for next 12 hours. Well, this is partially wrong. You can connect to a virtual machine and not render at all, and that session will only last 12 hours. And then Google will revoke your GPU system, replace it with CPU. But if you are connected to a virtual machine and rendering frames, you would only be able to render around 5 to 6 hours. And then Google will revoke GPU and replace it with CPU session. But imagine you had rendered 2 to 3 projects and you are about to render 4th project which has 300 frames, and after rendering 250 frames, Google revoked GPU and set you back on CPU. Now you can't render rest of the frame and also you can't download 250 frames that you already had rendered, which is annoying. That's where Google computing units come handy. I cannot explain how I came up with these numbers. I just did some math and bench test over Colab and found these numbers. So imagine you're connected to a Google system and assume you have 14,850 units. Now how would you know how much units have you used? On cell 5 of Colab Script, while rendering, you will see after each frame, it shows how much time it took to render a single frame. Let's say first frame rendered at 40 seconds. So I'll divide 40 seconds with 6 and multiply it with number of frames that I am about to render. In this case, I have used 1333 units, which means I am left with 13,516. Once you have calculated how much unit you have consumed, you can also calculate how much hours it will take to recover those units. You will be able to recover those units only after you have disconnected the session. Just take used unit and divide it by 1200. In this case, you can see I have to keep Colab disconnected for 1.1 hour to recover 1333 units. Let's say I have rendered heavy scene which used 5000 units. Divide that number by 1200, 4.1 hour to recover them after disconnect. If you have used entire 14,850 units, then it will almost take 12 hours to recover. Take a screenshot of this frame if you want to keep a track of it. This helped me optimize render time. I hope this helped you.